Okay, good morning. So we continue the lesson which was about the chain rule. So let me just remind you what was that. If you have two functions, f and g, one of them is acting after the other. So we have f of g of x. And then, of course, we want to take the derivative of this new combination, okay? We want to take the derivative of this new emerged function. For example, if I have g of x equals to x squared plus 2x, and if I have f of x equals to a square root of x, f after g means which function? F after g means first g applies to x, which will give me x squared plus 2x. And when I get the result from the first function, I apply the second function on the new input. So the new input is x squared plus 2x. F sends any input x to a square root of that input. Now the input is x squared plus 2x, so this output of this becomes the square root of x squared plus 2x. Yes, so that is the meaning of f coming after g. Okay, so the chain rule tells you how to take the derivative of f after g. And the formula, which I just wrote on the board, I haven't convinced you that this formula should be correct. That was this formula. F prime of g of x multiplied by g prime of x. Okay, so let me just remind you again. I told you that we don't use this method. I also talked about how to take u, making it faster. But if you want to calculate this, on the right-hand side, you have g prime. So it is very simple to calculate g prime. So g prime of x is equal to 2x plus 2. Here, it is f prime. So it means somehow I need to calculate f prime. Hopefully you remember this. So f prime of x is 1 over 2 square root of x. But the point is that this is not f prime of x. It's f prime of g of x. So this means that when I calculated f prime, where the input is x, I have to change the input of f prime to g of x. So this is f prime of g of x. But what is g of x? G of x is this. So this becomes f prime of x squared plus 2x. And then if I ask you what this is the new input for the function f prime. So I take the input and replace it with this one. So this becomes 1 over 2 square root of x squared plus 2x. And then I found the answer to this. I found the answer to g prime. According to the chain rule, in order to find the derivative of this function, I just multiplied these two. So the question mark is equal to 1 over 2 square root of x squared plus 2x multiplied by 2x plus 2. So this is the derivative of this function. But I told you that this is the way that you need to understand it, but you really don't need to go so long to answer this question. So if I give you this, there are many exercises like this in the book. So what I expect you to do is this. I give you this function h of x equals to square root of x squared plus 2x, and I ask you to differentiate it. So do you remember I wrote this formula in a slightly different way? I denoted this by u, and then this becomes u, and then this becomes u prime. So I wrote the formula like this, that f of u prime is equal to f prime of u multiplied by u prime. That's exactly the same formula, but written more compactly so that we can use it more effectively. So if you want to use this is the way that I always do it, and that is enough. You really don't need to motivate all these things to write, and it's better not to do that. So what do you do? So here you take this one to be u, okay? And then you will have a square root of u. If I ask you, do you know the derivative of this one? You can pretend that u is x. So the answer is 1 over 2 square root of u. In the case that this is x, this is finished. But do you remember? Every formula that you had for x, you can also write it for u, but there is only something that you have to remember, multiply it by an extra u prime. So then it becomes u prime. So you see, this formula I expect you to know, of course not to know, but if you don't know this specific formula, you have to derive it. It's not in the formula sheet. That's why I'm saying that remember this one. So assume that you remember this one. So the answer to this, you know it is this one. But writing it for u, where u is not necessarily x, is just a function of x, is equal to 1 over 2 square root of the same thing. You see, this part of the pattern is the same as if you have x, but the difference is this u prime. In this case, you also have x prime if you want to, but x prime is 1, so it doesn't make any difference. So this is why we don't write it at all. Okay, so if you want to calculate this, you would say that h prime of x is equal to the square root of u. The formula is similar to the formula that you get in the formula sheet, so it becomes 1 over 2 square root of u. But the point is that this is not finished if this is not x. It continues with multiplication by u prime, which is x squared plus 2x prime. And then you have to continue this process until there are no prime left. So it means that I have to copy and paste this part and what to do, and then take the derivative of this one, which is extremely simple. And now there are no primes left, so that's the final answer. And you can see that this answer is here. So you really don't need to find f, to find g, to write all these things. So what I expect you to write is just write this one. Yes? Is that clear? So that is a little bit of recap from what we had before. Okay, but let me also see this formula from a different perspective now. You see, you might first, if you didn't know about the chain rule, you might think that these two are the same. You see, this prime is here. In this one, the prime is just here. Yes? You might think before this lesson, you might think that these two symbols mean the same thing. But apparently you see they don't. Yes? Because this one is not equal to this one. It's equal to this one multiplied by an extra factor u prime. So this is important, that don't get confused here. So it matters if you put prime up there or if you put prime here. I want to talk a little bit about this, okay? If I ask you to what does this symbol mean? F of g of x totally prime. I want you to understand the differences between this from another perspective and this one. They are not the same thing, okay? Putting a prime here is not the same as putting the prime here, okay? So what is the difference? This means that first in f, you have replaced x with g of x, then you get a new function, then you differentiate the new function that you got. Okay, so here what you do first, you do not start with differentiation. You start with substitution, and when the substitution is done, you get a new function and you differentiate it. But this is different. What I'm supposed to do here, I start with differentiation. You see, when I wanted to calculate f prime of g of x, I started with differentiation first, then I removed x with g of x. Okay, so this theorem shows that these are not the same. The matter in which you substitute and differentiate matters. If you first substitute and then differentiate, it is different from first differentiate and then substitute. Yes, so let me make it a little bit more clear. So for example, if I give you f of x, let me make the example simple, okay? F of x to be x squared x plus 1 to the power of 2. Or this is not a good example. Let me start with this example. And let me give that g of x is equal to square root of x. Assume that you don't know the chain rule, okay? Still, I can ask you to calculate this. But of course, because you don't know the chain rule, you cannot use the formula, but it doesn't mean that you cannot solve this. You can still solve it. Let us do that. If I want to solve this without the chain rule, if you learned what I said, which one I have to do first, substitution or differentiation? Substitution. So what I do to answer this, I momentarily come here and do the substitution first. What does it mean? It means that I calculate this one first. Okay, so this means that I go to my function and of course replace x with g of x. What is g of x? G of x is a square root of x. And then instead of x in f of x, I put the square root of x. So what will be the answer? This would be square root of x to power 2, which is x, and then plus 1 to power 2. And then I expand that, it becomes x squared plus 2x plus 1. So you see, I first calculated this by substitution. I got this, and if I ask you, can you calculate the derivative of this combination? You would say yes. So I would just write this and then start differentiation, which gives me 2x plus 2. So you see, I calculated that without even knowing the chain rule. I didn't use that. Okay, but now let me calculate this one because I want you to really feel the difference between these two. They are not equal, not in general. Okay, now if I ask you to calculate this, what should I do first? What should I do first? Tell me. Here I substitute first and then differentiate. The answer was that. Here I have to differentiate first. From which function? From function f. Okay, but function f, if I want to differentiate it, assuming that I don't know the chain rule, so what should I do? I have to expand it because I don't know how to do it. I expand it, it becomes x to power 4 plus 2 times the first one times the second one plus 1. And what I do, I differentiate it first, so it becomes 4x cubed and plus 4x. Do you agree? For example, I can also take 4x out. So this becomes x squared plus 1. So to calculate this, you have to calculate the derivative first, and when the differentiation is finished, replace x with g of x. So replacement or substitution comes second. So can you tell me what the answer is here? F prime of g of x. I go to the result of differentiation and I take x away and put g of x in. But what g of x is this guy. So I put that there. So it becomes what? 4 square root of x times the square root of x to power 2 is x, and then plus 1. So the answer that I get is this. The answer that I had before is this. And then you see that they are not the same. Is that clear? Yes or no? Okay. So the answers are not the same. So the chain rule tells you how they are connected all the time. The chain rule tells you that if you substitute first and differentiate second, it is equal to differentiate first and substitute second, but you have to remember to multiply by an extra factor of g prime of x. They are not in general equal. So the order in which you differentiate and substitute matters, okay? So, for example, now let us check the chain rule here again. If I take f prime of g of x, which is this one, according to the chain rule, and multiply it by what? Multiply it by g prime of x. What is g prime of x? G prime of x, I can calculate. This is g of x. G prime of x is 1 over 2 square root of x. And now let us see what happens. This is square root of 2. The square root of x and the square root of x are cancelled. These two will cancel that 4, it becomes 2. So this becomes 2x plus 1. But now if I multiply this in, it becomes 2x plus 2, and that's exactly this answer. So this tells you that these two are not equal in general, but if you multiply the second one by an extra factor g prime of x, then they are always equal. So that is the content of the chain rule from a different perspective. And that's also extremely important to understand. Any questions here? Okay. Okay, can you tell me under which circumstances or under which conditions, if any, these two symbols are the same? Can you tell me, is there any possibility that this turns out to be this? Because we saw that this is not always the case, at least that was the example. But do you think they are always not equal to each other, or there are some circumstances that they coincidentally become equal? Yes? This is not a hard question. You should be able to answer that. Do you think this is possible? It was not possible here, and we know that in general this is not true, that they are equal. But my question is now different. I'm asking you, do you think it is sometimes possible to have this scenario? Yes, please. When? When g prime of x is 1. Yes, because you see that what I'm saying, this formula is always true. Okay? Now my question is that, is it possible the left-hand side, which is this one, becomes equal to this one only? Yes, if I am lucky and g prime of x is 1, then there is no difference between them. So this happens if and only if, IFF means if and only if, g prime of x is equal to 1. In that case, yes, they are the same. Okay, so for example, is there any difference between this one and that one? Is there any difference between these? Because of that situation, no. But because if you compare this one with that one, x is playing the role of your g of x. Yes? And if you differentiate this, g prime of x is 1. So this is always the same. So when it comes to function itself, it really doesn't matter if you put prime there or if you put prime here. Okay? What about this thing? Do you think that they are the same? F prime of x plus 5 and f of x, let me write it like this. F of x plus 5 prime and f prime of x plus 5. Do you think that they are also the same? Yes, they are the same. Why? Because now if you compare this one with that one, what is playing the role of your g of x here? X plus 5. And your derivative is still 1. So this means that this is also the case, regardless of what function is there. Yes? Okay, so this is possible. So I would say that this is also good to know. But if this is not the case, you have to be really careful if you put prime up there or if you put prime here. And for the chain rule, it is extremely important to understand this better. What is the meaning of this? If I ask you to calculate this, you have to calculate the derivative first and then replace the x's in the derivative with g of x. So let me give you an example to make sure that you can calculate this. So if I give you f of x to be x to the power of 3 plus 5, if I ask you to calculate this f prime at x to power 2, okay, tell me how to do it. I give you this function and I am asking you this question mark. So what I'm supposed to do? Is this one similar to this one or similar to that one? Left-hand side or right-hand side? Right-hand side, because prime is immediately after f. So this is this thing, and you know that. Are they equal, by the way? Do you think it doesn't matter here? It matters, because this is playing the role of g of x. What is the derivative of g of x? Is 2x. So this equality you shouldn't expect, because this equality happens if and only if the derivative of g is 1, and you see the derivative of g is not 1. So you shouldn't expect that it doesn't matter, let us calculate this, it matters. Okay, but how should I calculate this? This is something that you really need to know for the chain rule, because if you want to use the chain rule, you have to know how to calculate this all the time. Okay, so how should I calculate this? Which one has the priority, differentiation or substitution? When you see this symbol?
Differentiation.
Differentiation. So remember, I don't know, do you want me to write this? So when you write f g of x and then prime, this means substitution first, then differentiation, yes? When you see f prime of g of x, it means differentiation, then substitution, yes? Something like this you can write in your notebook so that you don't forget. Okay, so here, if I want to calculate this, so you told me differentiation has a priority. So I go back here and I start differentiation. So f prime of x is equal to 3x squared. Okay, and now what should I do for this one? When differentiation is finished, I go in the derivative and replace x's with this function. So what does it mean? It means that I write 3, I have a power of 2, but instead of this x, I put this function in, so this becomes x squared. And the answer becomes 3x to the power of 4. This is a very simple example, but I really want you to understand what is going on, because this is very important to know. Yes? Okay, let me also ask you this. If I ask you to calculate f of x squared then prime, you expect that this answer is not equal to this answer because g prime is not equal to 1. But for this one, calculating this one, we have two methods. One method is the chain rule, and the other method is just using substitution first and then differentiation. But sometimes it does not work if the functions are involved. This is not always the case that you can just forego the chain rule and do it just a very elementary way. Because if the function is so complicated, the substitution and then differentiation probably is not a good idea. Of course, this always works because you can always substitute and then differentiate. But it is important to know the chain rule. So let us calculate this in two different ways. Method 1, using the chain rule. Okay. So how should I use the chain rule to calculate this? This plays the role of my u here. Yes, do you remember this formula up there? Okay, so this becomes f prime of u, which is x squared, but this is not finished, multiplied by an extra u prime, which becomes x squared prime. And then what happens, this x squared prime is just 2x times f prime of x squared, but I have already calculated f prime of x squared, which is 3x to the 4, so this becomes 2x times 3x to the 4th, so the answer becomes 6x5. So this is using the chain rule. Okay, method 2, not using the chain rule, yes? Okay, so what should I do here? If I don't want to use the chain rule, can I do that? Yes. But because this symbol means substitute first and then differentiate, so first I have to calculate this, you see? If I ask you what is f of x of 2, you have to go back to your f, do replacement, do the substitution first, take x away, and substitute x squared instead. So this becomes x squared to power 3 plus 5. Yes? And then I have a derivative for the new function. This is without the chain rule. So, but then this is easy because this becomes x to power 6 plus 5, and then I differentiate. What is the answer? The answer is again 6x to the power of 5. So this answer and that answer match. So if you know how to do it, you will get always the correct answer. But it doesn't mean that, okay, let us not learn the chain rule. Yes, you have to know the chain rule, okay? Because I can design questions that you have to use the chain rule. I will tell you how, for example. And there are some examples in the book as well. So do you understand what I mean? So if I want to summarize, in principle, you don't need the chain rule to calculate if you know what is the meaning. But the connection between these two are extremely important to understand when you are doing derivatives. So in this example, I solved this same problem in two different ways, using the chain rule, without the chain rule, and you see that if you do it correctly, the answers are consistent and the same. So is that clear? Okay, now let me go and try to give you some other examples which I see in the book. Other type of examples. So in those examples, you really need to know the chain rule. Okay, so what should I do? For example, let me give you an example. So let f of x, let me write h of x. Let h of x be equal to f of x squared plus the square root of x. So calculate, determine h prime of 4 if f prime of 18 is 7. So these kinds of questions. So I have given you a function h of x. I haven't given you the exact rule of h of x. I have defined my function h in terms of another function f, but I don't know anything about function f except one small piece of information, that the derivative of this unknown function at this particular point 18 is 7. And I am asking you to calculate h prime of 4. These type of questions are in the book, and they will also be in the national exam. And this is one of those problems that I cannot forego the chain rule. The reason is that, of course, I want to substitute and then differentiate, but the point is that I don't have f so that I can substitute and then differentiate. Yes, if I have the full form of f, the general rule of f, yes, always I can substitute and then differentiate. But the point is that I don't know anything about f except the derivative of that unknown function at a very particular point 18. And if I haven't done something wrong, I engineer the numbers in a way that you can solve this problem. If I change this number a little bit, you don't have enough information to solve the problem. Okay, so let us understand. You help me to solve this one, okay? If you want to calculate h prime of 4, what do you do first? For example, if I give you a function, h of x squared. If I ask you calculate h prime of 4, what do you do first? You differentiate that, it becomes 2x, and then replace x with 4. Okay, so this means what you are supposed to do. So the first thing that I have to do, I have to calculate h prime of x, because you told me if that was a normal situation, you differentiate first and then replace your x with 4. So this is why I start with this. But do you think is there any difference between this and that in this case? Or can I say that they are the same? Yes, in this case, yes, that was one of those exceptions, yes, you see on the board. If you have only x here, it doesn't matter if you put prime there or if you put prime here. So this is why this is correct. Okay, but what do I have for h of x? It is given something to me in the problem. Let us use that. So I open these brackets, and then instead of h of x, I use this information given to me. This I want you to understand. Can I just simply flip this prime here? This is some mistake students do, okay, the students actually make. Do you think this is correct now? No, because this prime is up there. So I can't do it, but I should remember to do what? To multiply by this one prime. So let me just repeat it again. Why even I started from here? I started from here because that's completely natural. Look here. If I give you this function and I ask you to calculate h prime of 4, what you do first, you differentiate first and then substitute x with 4. Replace x with 4. So that's the same thing. I started from differentiation, but because of this rule that we learned today, if this is x, it doesn't matter if the prime is here or if the prime is up there. And now, instead of h of x, I use the information given in the problem, I put it here, but you see these pairs of brackets are there and there is a prime here. And now I want to differentiate this. This you need to recognize this is the chain rule, and there is no other way to solve this problem. So this method 2 is not working here, okay, because I don't have f. I know only one piece, very single piece of information about it. Okay, so then I have to use the chain rule. So the chain rule tells me I can remove this prime and put it here, but the price that I have to pay is to multiply the derivative of this by the result. So that's the content of the chain rule. Okay, let us continue now. Because still this prime is left, I can do something with it. So this I cannot do anything because I don't have f. So let us copy and paste this part we cannot do anything for. But this hopefully you can do it immediately. The derivative of x squared is 2x. The derivative of the square root of x is 1 over 2 square root of x. So this is my h prime of x. Yes, is that clear? But if you tell me, do I really know h prime of x? I would say no, because understanding h prime of x needs understanding f prime. But I don't have f prime, yes? But they don't want me to calculate h prime of x. They ask me to calculate h prime of 4. So after differentiation is finished, can you tell me what I'm supposed to do? I want to calculate h prime of 4. So I have to replace x with 4. So what happens? This becomes f prime of 4 to power 2 plus square root of 4 multiplied by 2 times 4 plus 1 over 2 times the square root of 4. Okay, tell me, is that understandable? So I just had this differentiation, I replace x with 4, and let us just do some calculations. Okay, so this becomes f prime. 4 to power 2 is 16. Square root of 4 is 2. 16 and 2 is exactly 18. So this is why I'm saying that if you remember, I actually was waiting a little bit to calculate in my head. So this is the only number that I can give you. If I have given you f prime of 17, that was the end of the problem. I cannot continue further. Okay, so that is engineered in a way that you can solve the problem. But that is not a useless problem because it is testing your understanding about the chain rule. Okay, so this becomes times. 2 times 4 is 8, and this is 2 times 2 is 1 over 4, sorry. And then This is given to me in the problem, so I just write 7 and then multiply it by 33 over 4, and then you multiply that, so 241, I suppose, yes, divided by 4, whatever. So you just multiply that, you get the answer. So these kind of questions can be designed to test your understanding about the chain rule. So there is only one way to solve this problem, and that is using the chain rule. Okay? In this problem, yes, you can do, even though I recommend you to use the chain rule again, but of course you can have two methods. But here, this is one of those problems you have only one method to solve it, and that is the chain rule. So is that clear? Okay, so I want you to really, this is an important example, a type of examples that you might face in this part of the problem. Okay. I don't want to continue further. I want to spend a little bit more time. Then what is left actually is to prove a little bit why this formula is working. Okay, but that's a little bit a long proof, so I will keep it for the next session. But that is also optional. I'm just going through it because it is in the book. And what is in the book is not complete, because the complete proof needs something else, which you don't have it. And I will talk a little bit about that. But that session is only for those students who want to know where this chain rule formula is coming from in the first place. So is that clear, everything? So I really want you to understand this example. If you don't mind, let me just see if there is any problem in the book. I ask you to solve that. Or might be it's not still here. It will come later. Or might be, so let me see. I remember there are some problems like this in the book as well. So this is exactly one of those problems that you really need to know the chain rule. Okay, so what happened? Could you solve that? Okay, so that is probably easy. Let me also do it on the board immediately. So you want to calculate what? You are supposed to calculate h prime of 3. So what I'm supposed to do, let me just write it everything. So I have to start with h prime of x, but I know that there is no difference between this and that because this is just x. But h of x is given to me, so this is f of g of x. Instead of h of x, I put this, and I have a pair of brackets around, then I have a prime. But this is the chain rule, so I can flip this prime sign here, but the price that I have to pay is to what? To do what? To multiply it by an extra g prime of x. So this is the whole thing that you really need to know. And then they are asking you about h prime of 3. So what I do, I put h prime and replace x with 3. When I replace it with 3 here, what I'm supposed to replace every appearance of x with 3. So this becomes f prime of g of 3 multiplied by g prime of 3. Yes? Okay, now you have to calculate these parts. But that is very strange. They cannot solve it, can they? Am I written it right? Or this is g prime or g? So g prime of 3, oh, okay. Yeah, that is, yes?
I put in the value of g prime, since we know that h prime 3 and g prime 3, x is the same, you can put in the values.
Yes, I can put the values, but I don't see the value for g of 3. But the point is that we don't need it. I was confused here. So the reason is that they have given you this function so simple that it doesn't matter what g is 3 is. That is why I was confusing, because I was carrying that logic with me here. It's much simpler. So g prime of 3 I don't have any problems with, yes? Because that's 4. So the only problem is here, and in general you cannot solve it because you don't know g of 3, but they have given you a type of function that this is irrelevant. Why? Because if I ask you to calculate this, by the way, how do you calculate this? If I ask you to calculate this symbol, this prime is immediate, so it means that you have to do the differentiation first. But when you differentiate, it actually doesn't matter what value of x is, because the derivative is always 2. So if the derivative is always 2, the derivative at this point is also what? 2. But if you ask me, do you know this number? I would say no, because I do not have g. But this is a very special case that it doesn't matter what this value is. So the derivative of this function is always 2, regardless of the value that you put in. So if this is the case, f prime of this number, whatever this number is 2 again. Is that understandable, this logic? And then it means that instead of this one, I put 2, and then I multiply it by g prime of 3. So the answer to this problem is 8. I would consider it a good problem because I was also confused here. But the next one is actually a hard problem. Okay, so let me show you here. When the lesson ends, do you know?
In 20 minutes.
Okay, so we have time. At least I want you to think a little bit about this. These problems are very common in national exams. Okay, so let me make it a little bit smaller. Okay, so the question is this. We are supposed to determine using this graph given here. Be careful. Some of these graphs are derivatives. This graph is g of x. And then you are supposed to calculate h prime of 2 if h of x is this guy. Okay, this is a mistake if you start guessing the functions. Okay, so you say that, okay, this is x squared. No, if you just do this guessing, then you will get 0 points. Okay, because there is no guarantee that this is x squared. So, because I would actually be more explicit, I would say that this might be part of a graph. We don't know what's happening later. Or even you cannot say this is a straight line, even though it is, but you don't know what will happen after that. So you just have information regarding this part of some graphs. Might be this is not the whole story. The purpose of this question is that this local information is enough. Even if you don't know what happens for these functions later, this local information provided for you, that is enough. So, because I have given this in the tests back then, and the people write that, okay, this is x squared, and they got the correct answer because the reason is that they had this in mind when they wanted to design the question. Okay, but I can promise you, I can engineer it in a way that this is not like that. So you need to know the real, and in the national exam, usually they are more careful about designing questions. So you need to understand how to use this local piece of information, even if this is not the whole story. And that is, by the way, very important, because when we have derivatives, we know what is happening around us. We don't know what is happening on the other side of the universe. So this is called local property. And if you want to say something about the whole universe, that is global property. And we have local geometry, we have global geometry. Okay, so I mean, that is important to understand that derivative is a local concept. So if you want to understand what's going on, local information is enough for you. Okay, let me wait for you. This B is much harder, but A is reasonably good. But remember, this is not G, this is not the graph of G, this is graph of derivative. And that's the graph of derivative, and you're not allowed to have any guess for the functions and try to solve the problem. Okay, I will give you 5 minutes at least to think about it. Let me repeat, you can use the information here. For example, you can use the grids and everything, okay? But you cannot guess the whole function, that's what I'm saying. You have to use the information provided for you here. Okay, so let us solve the problem, okay, together. Okay, you can help me to solve the problem. You just tell me, okay? I have written what I have. I have given this function, I am supposed to calculate h prime of 2. So you have enough experience to know where to start, yes? Where I'm supposed to start, I want to know something about the derivative of h, so I start calculating h prime of x first, in general. But we just learned there is no difference between this symbol and that symbol, and you need to know the answer. Why? Because this is x and the derivative of x is just 1. In that case, these two symbols mean the same thing. Okay, but then instead of h of x, I put this expression. So you see, I keep these pairs of brackets and the prime sign. I take this away and just replace this instead. So this becomes f of g of x. But then you immediately realize this is just a chain rule. So then it becomes that I can flip the prime in, but there is a price to pay, and the price is to what? To multiply by g prime of x as well. Yes? And now this is the part I want to calculate h prime of 2. So this means, therefore, what is h prime of 2? H prime of 2 is equal to, everywhere that I see x, I replace it with 2. This becomes f prime of g of 2 multiplied by g prime of 2. Okay, let me stop here. Do you understand what's going on exactly? Okay, so there are two pieces that I have to read from the information provided for me in the picture. I think this is the simple one first. I want to know what is the value of g prime of 2. So which one of these graphs contain the information for me? The yellow, because this is just g prime of x. But I want to know what is g prime of 2. Yes, here this is 1, so the next number is 2. Yes, because the one grid is 1 according to the information. So then I go vertically up, and then I intersect the yellow graph here. Is that right? And then I read the number here. What is this number? 4, because the grid on the vertical axis is also 1 unit. Yes? So if I ask you what is g prime of 2, what is your answer? 4. So let me know if you don't understand. Do you understand what's going on? So I want to calculate g prime of 2, so I refer to the graph of g prime of x in the picture and try to see what happens for my function when the x value is 2. I calculated that, I didn't calculate, I just read it from this one. So this is 1, 2. I go vertically up so that I can intersect the yellow graph and then go in this direction, I get 4. Okay, but this one needs two things, because this is f prime of g of 2. So which graphs are involved? I need two graphs. I need one graph for g to be able to read this piece of information, this thing. And then after that, I need the graph of f prime. Yeah, the graph of f prime is also given. Yeah, so what I have to do, you need to read what is g of 2. So which graph is useful for reading g of 2? The blue one, because the blue one is given to be g of x. So I go again here too. I go vertically up so that I intersect this time the blue one, but this is coincidentally the same. Yes? So if I ask you what is g of 2, the answer is coincidentally 4 again. So this is 4 again, but this is what I want to calculate is f prime of 4. Yes? So to answer the f prime of 4, what I have to do, I have to refer to the red graph. So what is f prime of 4? I go and find 4, 1, 2, 3, 4, and then I go vertically up so that I intersect the corresponding graph, and then I go horizontally. What point is that? 1, 2, 3, 4, 5. Yes? So this means that in one step, I was able to read this and that. I got this. In the second step, this is 5 and that is 4, so the answer is 20. Okay? So I really recommend you, the part B is quite harder. Okay? So I will start with probably solving this problem for you next time. But
if you don't think about it before, it is useless. Of course, you will understand what I explain here, but the point is that you need to be able to get the answer yourself in the exam question. Okay. Yeah, and then of course, if there are some other hard questions, I will solve the problems of those types for you as well. Okay, any questions? Thank you very much.